Hi, this is Chycho. That's it. Hi, this is Chycho, end of May 2009, and welcome to Series 3 of the Language of Mathematics. Now what we're going to talk about in this series is going to be from what I figured out to be the most important symbol in the language of math, which is the equal sign. But before we get into understanding the equal sign, which is really directly related to units, units are basically specifying what it is that we're talking about in math, right? But before we get into that stuff, we have to do a little recap of what we've covered so far, which is basically dealing with the real number set, dealing with operations, addition, subtraction, multiplication, division. So basically crunching numbers. And what we did was, because we were going to get into stuff as fast as we can, we also introduced exponents, which was in Series 2, with radicals. So exponents and really radicals are the same thing, just fractions and not fractions, right? If you need a recap, if you don't know what I'm talking about, take a look at the videos. What we're going to do right now is go through the stuff really quick and then start talking about how it relates to the equal sign, okay? So let's go to a little wall here and just do a little quick drawing sketches and visually try to understand or remember what it is that we talked about before and how it applied everywhere, okay? Let's go. Okay, if you remember, the first stuff we got into when we started talking about the language of mathematics was the real number set. So let's do a little sketch of it and talk about each subset and just go through it really quickly, okay? So we talked about this before, and basically this is the real number set. And what we have on this side is the rational numbers, and on this side are the irrational numbers. Now, rational numbers were broken down into 4 categories. The natural numbers were the counting numbers, 1, 2, 3, all the way up to infinity. You had the whole numbers, which was the introduction of the number 0. And then you had the integers, which was positive and negative whole numbers. And then you had rational numbers, which were fractions of integers. Anything that you could write as a fraction of these guys is a rational number. On this side, you had the irrational numbers, and the irrational numbers are anything that you cannot write as a fraction of integers. Integers, or natural numbers, are really prime numbers. And again, we went into a lot of detail in this in the first series. So if you need a recap of prime numbers, take a look at the prime numbers video. So with the real number set, if you break it down to its basics, is this side is anything that could be expressed as a fraction of primes, as number 1 or as number 0, and this side is anything that cannot be expressed as a fraction of prime numbers. Okay? And that was the real number set, right? From here, we went and dealt with, we learned how to deal with the numbers, and from there we introduced operations. So we took numbers and we said, okay, what can we do with these numbers? Well, we added numbers, we subtracted numbers, we multiplied numbers, we divided numbers. So from here, we came and we added, the plus sign, the subtraction sign, the multiplication sign, the division sign, which is basically the 4 ways that we deal with, the real numbers. So there's a whole bunch of videos that I've already done which deals with this and deals with operations. And then what we decided to do in Series 2 was introduce another layer to our numbers, basically kick it up to another level. So initially we had, for example, we were going 2 times, does it show up? Let's do green. 2 times 5 would have been 10, right? So this was our regular operation with the real number set, taking our rational numbers, these are just integers, or natural numbers, right? You could go negative 2 here, all of a sudden it becomes an integer, right? So we went 2 times 5 is equal to negative 10. You got negative times positive. Negative times positive is negative. What we did, we introduced exponents. So we took our base numbers here, right? And we said, hey, what happens if you put a number here? What does that mean in the language of mathematics? What does that symbol do? So if we put a 2 here, all of a sudden we had exponents. And what we did with exponents was, hey, we created rules to represent our, to deal with the symbols that we've created. So we took our operations really and applied them to exponents. So in multiplication, these two numbers multiplied together gives you 10. If you had two things multiplied here with the same base and could be different exponents, those guys added. So series 2 deals with this stuff, series 1 deals with the real number set and the operations, and it also has a section on trigonometry and geometry, which we're going to talk about more again in every series. It's just going to grow and grow, right? So we're going to take all this information from series 1 and 2 and apply it somewhere. And as soon as we apply it somewhere, we're talking about the equal sign. And when we're applying it, we have to know what we're talking about. And that implies, specifying what units we're talking about. So we're going to take this information, apply it somewhere, which is basically dealing with the equal sign. And when we're applying it, we're going to assign units to our numbers, right? So we're going to try to see if one thing equals another thing, right? I think this comes up everywhere, in sustainability, when you're talking about the environment, in equality, if you're talking about human rights, in business, liabilities, assets, you have to balance the budget, right? What's going to happen is, we're going to take things and, try to see if they're equal to each other. So for example, let's do the real number set, right? When we did the series and when we draw the real number set, or when I draw the real number set, I break this up into two separate halves, right? And equal halves. But in reality, there's a lot more irrational numbers than there are rational numbers. So visually, this is really good just to remember, how this is laid out. But in reality, there's way more irrational numbers than there are rational numbers. So they're areas, and we talked about this in geometry. If we haven't talked about it, we will talk about it. The areas of these two things may be equal visually, but the number of numbers we have here is way less than the number of numbers we have here. So these two sides in reality are not equal when it comes to quantity anyway, when we're talking about quantity. Visually, yeah, the two areas we draw as equal areas, right? So we're going to take these rules and apply them places and, learn how to, again, crunch numbers that have units in them and try to balance our equations. And then we're going to talk about getting into functions. This goes directly into functions and trigonometry, right? Where we did graph, x, y axis, and we're going to graph things and follow them up as functions. So series 1, learning about the real number set, trigonometry, geometry. Series 2, we learned about exponents and how to deal with our operations and exponents. And series 3, we're going to take everything that we learned in series 1 and series 2 and apply it. And, see where we go with it. And this might be a continuing because, you can apply mathematics anywhere. You can talk about mathematics, use mathematics to talk about